Most Python ideas begin in a notebook, a terminal, or a script that only the author can comfortably use. That is fine for exploration, but it creates a wall between the logic and the people who need to touch it. Streamlit turns that wall into a canvas. You keep writing Python, but the result becomes a real interactive app. Controls, charts, tables, and outputs that teammates can open in a browser. The important shift is not cosmetic. It is the difference between code that proves an idea and an interface that lets the idea travel. This is the old bottleneck. Brilliant logic gets trapped behind a command line. The engineer knows what argument to type, which file to load, and what output matters, but everyone else sees friction. A tool that requires instructions before it can be used is already fighting adoption. Streamlit solves the presentation problem without asking data scientists or AI builders to become front-end specialists. It gives Python code a visual surface, so the same model, analysis, or simulator can be tested by people who never want to see a terminal prompt. Traditional web apps usually split the work across front-end languages, back-end services, UI frameworks hosting, and state management. That stack is powerful, but it is heavy when the goal is to share a data product, prototype an AI assistant, or expose a model workflow. Streamlit compresses that distance. A pure Python script can become a working browser app in minutes. This is why it matters for data scientists and AI developers. The shortest path from useful logic to useful interface often wins. Think of Streamlit as the missing presentation layer for Python. Your backend logic stays where it belongs. Data loading transformations, models, charts, API calls, and decisions. Streamlit adds the user interface layer on top with widgets, layout primitives, and automatic reruns. A slider can become an input. A data frame can become an interactive table. A chart can become a live visual. The code is still Python, but the audience no longer has to think like a Python developer to use it. Streamlit grew quickly because it matched a real behavior. People were already building internal tools, dashboards, model DMOS, and decision aids in Python. What they needed was a way to share them without weeks of web engineering. Its adoption by enterprises reflects that practical value. The tool became especially useful anywhere teams needed fast iteration. Analytics, machine learning operations, and product experimentation. The lesson is simple. When a framework removes the last mile between analysis and action, it becomes part of the workflow. The Streamlit trifecta is velocity, simplicity, and synergy. Velocity means an idea can become a demo before momentum fades. Simplicity means the app reads like normal Python instead of a maze of event handlers. Synergy means Streamlit works naturally with the rest of the Python ecosystem. Pandas, NumPy, Plotly, Matplotlib, LangChain open AI tools, local models, and databases. It does not replace the Python stack. It gives that stack a front door. The syntax feels direct because Streamlit maps code to canvas almost one-to-one. If you write a title appears. If you create a slider, the user gets a control. If you chart a data frame, the chart appears in the app. This is powerful because it keeps the mental model small. You do not have to wire up callbacks before you see value. You can describe the interface in the same script that performs the computation, which makes prototypes easier to understand, modify, and teach. There is a trade-off. Streamlit gives you beautiful defaults and fast interactivity, but it is not trying to be a pixel-perfect front-end framework. Fine-grained CSS control, complex animations, and highly custom product interfaces may still need traditional web tools. But for internal apps, experiments, data workflows, and AI prototypes, that trade-off is often exactly right. You give up some microscopic control in exchange for a working application that can be used, reviewed, and improved today. Streamlit is especially strong for data science because it treats data outputs as first-class citizens. Tables, charts, maps, metrics, and file inputs are natural building blocks. A pandas data frame can move from analysis to interface with very little ceremony. Visualization libraries like Plotly, Altair, Matplotlib, and PyDeck fit into the workflow. That means the app can show not only a final answer, but the shape of the evidence behind it. For decision tools, that transparency is often more valuable than a polished shell. Large language models made Streamlit even more important. AI projects need fast feedback loops. Prompts chain, retrieval pipelines change, models change, and the right interface is rarely obvious on day one. Streamlit gives builders a place to test those loops in public enough to learn. You can expose a prompt box, show retrieved context, compare model outputs, display latency, and collect reactions from the team. Instead of a hidden notebook, the AI system becomes an interactive experiment. A chatbot is a perfect example. In a small amount of Python, you can connect a model API, accept user input, keep session state, and display the conversation. That does not make every production concern disappear, but it does let teams validate the experience quickly. The real value is speed of learning. Can users ask the right questions? Does the app need memory? Should answers include sources? Streamlit helps answer those questions before the project gets buried under infrastructure. Deployment is another reason Streamlit spread. A local script can become a shareable link through Streamlit Community Cloud or a private deployment path. The basic loop is simple. Write the app, push it to a repository, and deploy. For teams that are used to API servers, containers, and front-end builds, that simplicity can feel almost suspicious. But for many analytics and AI apps, the fastest useful deployment is the one that gets real users into the loop. The bigger idea is this: Streamlit is the UI layer for the AI era. AI builders are constantly turning models, workflows, and data pipelines into tools people can actually use. Streamlit sits at the moment where code becomes experience. It is not always the final production framework, and it does not need to be. Its strength is helping useful Python escape the notebook, reach real users, and evolve through feedback. That makes it one of the most practical bridges between AI engineering and everyday work. If this helped you see Streamlit as more than a dashboard tool, subscribe to Life of Geeks. I break down practical AI engineering, local tooling, and the frameworks that turn experiments into real products. Comment STREAMLIT if you want a starter template for an AI app built with Python Streamlit and a clean deployment workflow. Thanks for watching, and I will see you in the next build.